Compound conditionals. Imagine your 5-person band gets a gig, and you have 450 pounds of equipment to haul from your van to the stage. You know that each member of the band can carry 50 pounds of gear per trip. But if anyone has to make more than 2 trips, they swear they will quit on the spot. So you do some arithmetic to figure out whether or not the band should accept the gig. So let band member count get 5 because you have a 5-person band. Let weight per person get 50 because that is the maximum amount they can carry per trip. Let maximum trip count get 2. So because if anyone has to make more than 2 trips, they will quit on the spot. Let gear weight get 450 because that is the total amount of gear that you have in pounds. Let total carrying capacity get band member count times weight per person times maximum trip count. So this is how many people you have, how much each of them can carry for one trip, and then how many trips each of them will take. So if gear weight is less than, so gear weight here, total carrying capacity, rock on. Else, everyone quits, looks like you've got a solo show. So right now, we see that this evaluates to 500, and gear weight is 450, so this is true. So gear weight is less than total carrying capacity because 450 is less than 500. So we are rocking on. No one quits. So then you take a gig and your band quits anyway. One of the pieces of equipment weighed 100 pounds and it was raining when you arrived. Nobody wants to get wet hauling the heavy gear. So it looks like your decision is more nuanced. If rain seems probable, you shouldn't have any gear that's difficult to carry. In summary, you should only take a gig if you can handle all of the gear in 2 or fewer trips, and either it's unlikely to rain or you don't have any especially bulky gear. That's doable using some if-else magic, like this. Let chance of rain get, this is a double, 0.5. Let bulkiest item weight get 60. If gear weight is less than total carrying capacity, that is true. So we are going to run this nested if statement. So if this was false, it would just say else everyone quits. So this is true, so we are going to continue looking at this. If bulkiest item weight is less than 80, so bulkiest item weight is 60, so this is true, it is going to say rock on. If this was not true, it would check chance of rain. Is chance of rain greater than or equal to 0.1? Chance of rain is currently 0.5, so this would be true and everyone would quit. But because our bulkiest item weight is less than 80, we are rocking on. So they are okay with carrying that in the rain. That code is less than elegant. One result is duplicated due to the complex logic expressed by multiple if-else statements. In addition, so we have 2 everyone quits. In addition, the nested code isn't very clear to read. Any manager that came after you would have a hard time tweaking your algorithm, and of course, adding new factors would produce even more tangled code. The solution lies with Boolean operators. The key terms from your complex decisions are the words and or, which correspond directly to operators that combine 2 bool values and evaluate to a bool result. The Boolean and operator is written ampersand, ampersand, so the and sign twice. It is called an ampersand. It produces true only when both its operands are true. So false and false evaluates to false. So both of those are false, so it's false. True and false evaluates to false because one of them is false. False and true also evaluates to false because one of them is false. And true evaluates to true. If you think of, if I said, Please stand if you are wearing blue and green. And you only had blue on, you wouldn't stand. If you had neither on, you would not stand. If you only had green on, you would not stand. But you would stand if both of those were true, blue and green is what you were wearing. The Boolean OR operator is written with these two vertical lines, which are above the return key. It produces true if either or both of its operands are true. So false or false is false. So if I said stand if you're wearing green or blue and you didn't have either one on, you would not stand. That is false. True or false. So if you had green or blue on and you had green on, you would stand because that is true. One of those is true. False or true. So if you didn't have green on, but you did have blue on, you would also stand. And true or true. So if I said stand if you're wearing green or blue, and you had green and blue on, you would still stand. So that is true. So just one of those has to be true for the OR operator to be true. You can combine simple conditionals with these operators, as well as the Boolean NOT operator, the exclamation point and parentheses to form new compound conditionals. Equipped with these new tools, you could write different versions of the code. Compare the code below to the one above. Will they have the same or a different result? If gear weight is less than total carrying capacity, and then these parentheses make this statement evaluated first, chance of rain is less than 0.1, or bulkiest item is less than 80. So the first thing I do here is see if chance of rain is less than 0.1. And if one of these is true, or bulkiest item weight is less than 80, if one of these is true, this parentheses evaluates to true. Then we're going to look at gear weight less than total carrying capacity. If gear weight is less than total carrying capacity and one of these is true, this is going to evaluate to true. If this one or this or, if either one are false, the and evaluates to false. So right now it is evaluating to true. So we are rocking on. Else, everyone quits. Looks like you've got a solo show. This code has the same effect as the one above, although this code is much cleaner, but you can still do better. Next, we're going to learn about using functions as conditionals to completely encapsulate complex decisions.